Hello, everybody. My name is Matthew Benedum, and my partner is Desmond Marhal. And today we'll be presenting our Mechatronics final project, which was our robot that follows the line. So to start off, we're going to explain how the code works, or the algorithm. So essentially, the main way our code functions is it has multiple stages, as you can see here. And the main loop of the stage, go back here. The main loop of the stage has multiple different stages. So if the stage variable equals 0, it goes through the first stage of the sequence. If the stage variable equals 1, it does the stage 1 code, and throughout the rest of the code, it follows the same pattern. In the first part of the code, the first sequence just serves to set up the components that are part of the robot, that being the servo motors, the LCD display, the LEDs, and the light sensors. And the void setup loop does the same thing. So now I'll get into what happens in each of these subcodes, that being stage 1, stage 2, and stage 3. So in the stage 1 code, the main responsibility of the stage 1 code is to get the robot to the line. So it starts off by reading each of the sensors in the front. So what these tell the robot is if it's over white or black. So if it's over white, it'll tell the robot to keep going, and if it's over black, it'll tell the robot to stop. And you can see that more clearly here. Right here, it's setting the motors to drive forward for a short period of time, 0.1 seconds, and then it stops them. Then finally, it checks to see if any of the sensors are picking up any black. And if they do, it stops the robot for a second, and it will then just move it a little bit forward so it's perpendicular and in the middle of the track. Then in stage 2 is responsible for orienting the robot to be parallel with the line once it has hit the line. So just like the last code at the beginning, it reads the 3 sensors right off the bat and maps them to their corresponding values from 0 to 100. Then it sets the servos so the robot is turning in place. Once the robot is turning in place, it continually checks sensor 1 or sensor 2 or 3, which are the 2 sensors on the far end, to see if they hit black. Once they hit black, it initializes stage 3 of the code. Then stage 3 is the main algorithm that helps the robot follow the line. So just as it did in the last 2, it starts off each sequence by reading the sensors. Then it has a large if-else statement that basically has 3 different functions. So what this is telling the robot to do is it's checking more specifically in between the left and right sensors, so that if the left sensor is picking up, or actually this would be the right sensor. If the right sensor is picking up black, it'll tell the left motor to spin more, so it follows the curve. And likewise, if the left sensor, this is the left sensor, this is the right sensor. If the left sensor is picking up black, it'll tell the right motor to curve more. And if neither is picking up any black, it'll just tell the robot to go forward. And after it tells the motors to turn for a little bit, it stops and then adds 1 tick to the total. So the way this code functions is it basically does many increments. So every time it goes through, it reads the sensors, it moves the robot a little bit a certain direction, either left, right, or straight, and then it stops, adds a tick, and then it repeats. So lastly, this last section of the code right here, if ticks equal 20, m right 0, this statement is responsible for the drop block mechanism. So essentially what happens is once the robot gets a certain distance along the line, it's about 1 or 2 inches, it drops the block so that it's centered within the line. So that is the main functions of the code.
The marking system for our robot is pretty simple. We initially put a black marker onto a standard servo, and when we start the robot, it will find the line. Once it gets aligned with the line, it is ready to go into the stage 3. It will drop the black marker right on the line. And once the robot eventually completes the